Okay, now this question 4 is a really good question and a really important question. Okay, this is the one that you do not want to miss out of your homework because you couldn't sort it out. Because we're going to sort it out. Okay, right, what's going on? We've got a line, we've got a curve, and we've got a tangent. Okay, all right. A line and a curve, what happens when a line is tangent to a curve? So I'm going to draw any old curve here, and I'm going to draw a tangent to it, okay? So we've got a point in common. So finding a point in common, if you actually were finding the point, okay, you've got the equation of the line, you've got the equation of the curve, and this is, if you like, a point of intersection between the two. So intersection, you should know what you do. You solve simultaneous equations. You need two equations. So at this point that they have in common, okay, we have got that equation and we have got this equation. So you think about how you would solve those equations, and you're going to get an equation that you would solve if you had both equations and you wanted to find the coordinates of the point. But we actually don't know this equation in full, and what we do know is that there is just the one point. Okay, so if you've got a line and a curve, we've got this situation where it's a tangent, not this situation where it misses the curve completely, and not this equation here where it cuts the curve twice. So the kind of equation you get might just possibly be a quadratic equation. So you need to think about, okay, that quadratic equation, I don't want one of these as two real roots. I don't want one of these where there's no point of intersection at all, so there aren't going to be any roots. I want one of these where there is just one solution to that quadratic equation, but it's a repeated solution. So having set up your equations, you're going to start with this, and you start with this, and you're going to get something you can rearrange to equal 0, and it will have x squareds in it and x's and blah blah blah, and it will have this c in it somewhere. Okay, but then you'll say, okay, so we want tangent is going to mean the fact that it's got to be a tangent means that there is just one intersection point. Okay, which means, therefore, we have got some particular type of roots. So, therefore, there is some chunk of algebra, okay, with A's, B's, and C's in it, that has to have some particular relationship with 0, okay, so a greater than 0, or equals 0, or less than 0, say which. So, okay, so we're going to have bracket squared minus 4 bracket, and we're going to have some symbol equals 0, okay, and out of the end of it, we're going to want to end up with the value of c. We're going to want to find out what c is. Okay, and if you do all of that carefully, that should be okay. And I think you've got an example in your notes where something was a tangent. Okay, well actually it wasn't quite a tangent. It was example 6 on page 47 of your notes, and it had a bit where you had to show that there were points of intersection. So it was a similar kind of method to this. So that might be a good one to have a look at. Good luck.